Hello everyone, welcome to BCP Beat Check app demo. The app is really useful for tourists and local who wants to visit the Bournemouth Christchurch Poole coastal area. They can see the congestion status of the beach before they visit the area so that they are safe and can maintain social distancing. The app shows the congestion in traffic light like system in red and green flags. So let's quickly jump on to the app inside. Once we go for view congestion, the app shows the entire coastal line of Bournemouth Christchurch Pool, which is divided into different zones, and the zones are marked as red and green through AI backend, which gets the feed from CCTV and automatically push the status here. The status also there is an option to override by rangers or lifeguards who can override the status. We can also search for a particular beach area if we quickly want to jump onto a particular location. So we'll search for Bournemouth Beach West for the demonstration. And once zoomed in and we tap onto the zone, it will give us some more details about that particular beach location. It tells us the congestion status, current congestion status. It tells us whether it's lifeguarded, public toilets are available, dogs are permitted to exercise, cycling and BBQ, whether they are permitted. Along with that, it also tells us the forecast for next couple of days. The forecast can be viewed for entire coastal line from the map screen. We can quickly jump on to tomorrow and day after tomorrow, and it'll tell us the forecast for the entire coastline. Now, once we click on the more information, the I button, it gives us the option to showcase another locations around the beach area, such as the parking and toilet area, which user can quickly filter through. Along with this, the app has a feature for setting the accessibility setting for colorblinds who can replace the green, orange, red colors to color of their choices so that they can see those colors comfortably through the app. So along with this, there are features for giving the feedback and viewing the FAQ as well in the user application. Now we'll look at the backend AI and see how the data is being pushed and reflected here. Thank you.
Hello everybody, my name is Mark Parsonage. I'm from a company called Extension. We're based in Europe and we have customers around the world where we help healthcare facilities with their IT solutions. As part of this, we often integrate IT systems, and for this we have an enterprise service bus called Orchestra. Orchestra actually originated in the industry and business sector, so it's an ideal solution for the Beach App platform. On this slide we have an overview of the architecture that has been implemented for the solution, and today we're going to run through each of the various parts. So we'll start with the CCTV image processing at the top left here. We'll then look at the footfall sensors, we'll look at the prediction algorithm, and then we'll see how Orchestra brings all these different feeds together and sends them through to the API that powers the Beach app. So first we're going to look at the CCTV images and the historical data and how Orchestra handles these. So here is an example image of a beach, and here we're going to show you how we can analyze that image and establish whether it's busy or not busy. So you can quite clearly see that, as you'd expect, it's a picture of a beach, so the sand is predominantly yellow and it's the main part of the image. So it's fairly straightforward to see that if we can then identify the colours in the image, we can identify whether it's sandy or not sandy, which would be the case when there are a lot of people on the beach. So in order to isolate the area that we're interested in, we crop the image and target the beach area itself rather than the, in this case, hedges and cliff face around it. So here we can see the output of the analysis that we can run on the image. This black box in the middle is the sort of technical output, but around the outside I've put some colour explanations to make it a little bit clearer. So we can see the first sort of 3 parts of the image are the sand colour, and then the final part on the right here is sort of approximates to the top left, which if you remember was the sea. So obviously in the interest of GDPR we can't really show you a real image of people on the beach, so we've mocked up a preview of people, which just gives you an idea of roughly how it would appear when there's the beach is more busy and populated. So if you remember back, we also had the crop area, so you can imagine that we're focusing just on that middle area, so we've gone from quite a yellow image to one with all different types of colours but predominantly dark. And that difference is reflected in the processing that we do on the image. So you can see we've still got sort of some sand at the start here at the top. We've still got the sea because that's not changed at all, still 13%. And now we've got this 11% of kind of dark area. So that tells us that it's changed, and therefore we can tell that there's people on it because we can identify the different colours. So this one is obviously dark. And what we find is in the summer, the colours are a bit lighter. So you can imagine people come to the beach more in kind of lighter clothing or bright coloured umbrellas and the like. So once we've got the image data, we can plug it into Orchestra. And here we've got the flow that is created within the service bus. So on the left hand side, we take in the image, we get the image colours, which we've just seen, we parse out the parts we're interested in. We can then do what's called a mapping, so that's taking the colours, we run them through the algorithm, and that outputs a status. So that's a red, orange or green, which we can then send through to Expert Nest in order to power the app. And then on the right hand side here we've just got a bit of a technical section which is error checking and handling that side of things. So each camera points in a different place, so we have to use different values for each camera, and then we have it trained based on different factors. So we use historical images based on different levels of congestion and different weather conditions. So that way we know the sort of colours we're expecting. And then we see this as an ongoing process. You know, there's always opportunities to tune algorithms like this. So we store the data and the output so that we can go back and revisit it in the future. I'll now move on to the footfall sensors, because some areas of the beach aren't covered by CCTV so comprehensively. So we can take the data from the footfall sensors in. This is quite a straightforward flow really. They come in, we do a little bit of mapping to categorize the data, and then we send it on to Expert Nest to power the current status values in the app.
Hi, I'm Nick Giles, Chief Product Officer at Daisy. BCP Council uses the Daisy platform to manage low-cost Internet of Things devices across a range of use cases. These include air quality monitoring, real-time traffic flow, car park occupancy sensing, and high street footfall. The Daisy platform manages the life cycle of the equipment from sourcing and inventory through installation, commissioning, and in-life monitoring and alerting. For the Beach App project, the Council has chosen to deploy the NetSense's Wi-Fi occupancy scanner. This device is manufactured in the UK. It has a replaceable battery providing 2 years of autonomy, and it sends real-time data over the Vodafone NB IoT network. Low-power IoT devices can be really cost-effective at transmitting real-time data. A device such as this costs around £200, significantly cheaper than traditional footfall and occupancy measuring solutions. As it's battery powered, it can be placed in areas without the need to install power, communication or IT infrastructure, with a simple setup process through the Daisy mobile app. The unit passively scans its locality every 30 minutes, counting nearby smartphones with about a 50-metre radius as an indication to the number of people in the area. The data is completely anonymous and can't be used to identify a unique device or an individual. The sensors are managed within the DAISY platform, allowing BCP Council to monitor the health of all deployed devices across the conurbation, ensuring that they continue to send data throughout their life. As data is received, it's processed and normalized into standard formats for any application to consume. In the case of the beach occupancy project, device data is combined with project metadata to identify the beach segment, and this is published to the orchestra service bus as JSON data. A dashboard additionally provides a live view of the segment data with a geographic view of the project and historic reporting data. To find out more about the low-cost Internet of Things, please visit us at daisy.io.
And then the third part of our involvement has been the prediction algorithm. So this takes a number of inputs, so a weather forecast, which as you'd imagine is quite the most important part of it. Each of these inputs is weighted, and then we can sort of combine the values within them to generate a prediction of how busy we think the beach is going to be. So weather forecast, calendar. So again, the three things as you'd expect for when it's going to be busy or quiet, weekends, bank holidays, school holidays, and then we weight that in with some historical data for each location as well. So here's the weather forecast. The two main factors really are the maximum temperature that's predicted. So in this example, it's obviously quite a cold day, and then the wind speed as well. A quick one here, this is the calendar, so we've identified, as described, bank holidays, weekends obviously we know from the date, from just Saturday or Sunday, and then Christmas, bank holidays, so Christmas, New Year, etc. And then we've got the historical data which has been captured by the rangers and lifeguards on the beach. So we can see on the Friday, the 5th day along here, it's 20 degrees. And it actually reached a peak busyness, so 5 out of 5. This data flow monitors the weather forecast feeds. So this little green timer here is checking the feed every 30 minutes. It then takes that, it then pulls in the other factors for the prediction and generates the prediction, and then sends it through to the app. And here's an example of how it works. So you can see that location ID is 121 on the right hand side here. We've predicted a congestion level of 15 out of 100, and that corresponds to a flag colour of green.
Hello everyone, welcome back. Now that we have seen how the backend AI framework works, let's see how the status of the Bournemouth Beach West has changed once the data was pushed from the AI framework to this one. So now you can see the congestion status of the Bournemouth Beach West area has changed to congested for today, and also the forecast for tomorrow and day after tomorrow has been changed to congested status. So this is how the backend AI framework and the app, the changes are reflected in real time. Thank you.